Hey guys, what's going on? This is Caleb with DevSlopes, and in this video, we're going to be talking about machine learning. We're going to just kind of do a brief umbrella discussion about machine learning at large before we dive into the code and actually start using Core ML in our apps. First, we need to understand what is machine learning. We also are going to talk a bit about how it works and why should we be using machine learning. Okay, what's the point? Why should we do it? But first, let's go ahead and just talk about what is machine learning. Machine learning is basically a way that our programs and our applications can learn from various data that's been passed into our application and then make predictions based on that information. In the example of the app that you'll build in this course, we use Core ML, we use machine learning to classify information that comes in through a photo. Then our model, which we'll talk about the trained model later, basically the model is going to take that input data as a photo. It will analyze patterns it can see in the photo, and then it can use that information to make a prediction based on what it already knows. So that's pretty cool. A definition I really like of machine learning is right here, okay? And it's pretty vague, but I'm going to go into detail about it later. Machine learning gives computers the ability to learn without being explicitly programmed. So I did not have to write the code to tell my app how to identify a remote or a window or an umbrella. I didn't have to tell it to do that. I used a pre-trained model. Think of that like a brain. Okay, when you are a baby, you have a brain, obviously, but it's still developing. It's still learning and growing. So you need to have experiences. You need to be exposed to different kinds of information. You need someone to teach you, right? Maybe your parents teach you, oh, this is hot, right? Don't touch the stove. They tell you that it's hot, and you probably know that, but you don't understand and don't experience it until you touch the stove, and you, wow, that's hot, and you make that connection in your brain. A pre-trained model is kind of like that, okay? Data scientists are kind of like parents in a way, because they train these machine learning models to understand information and to classify it. So it's exposed to a lot of different kinds of information. Maybe the data scientists expose their model to hundreds of different pictures of TV remotes so that the model can identify, okay, when I see a shape that's about this size that has a bunch of square buttons in a certain grid and order with different colors, it knows to classify that and observe those patterns. And then based on that, it can make a prediction with a certain level of confidence. Okay, that's really cool. Now, basically, the computer has been trained. It's learned what makes a remote, what makes an umbrella. And based on its experience and what it's learned, it's able to make a prediction. Very, very cool. This technology of computers being able to learn without being explicitly programmed is pretty incredible in my opinion. And the implications of how machine learning could change the world and are changing the world go beyond just simple apps that classify photos. Doctors are using machine learning to identify and diagnose certain diseases. Okay, it could even be used for like relationship stuff. It can be used to identify patterns and habits, maybe for like relationship or matchmaking. It could be used to analyze very expensive and costly manufacturing procedures, like will this engine work or will a certain part fail? It could make predictions based on how it has been trained. Okay, there's lots of very cool ways in the real world that machine learning could be used. Okay, there are a couple different ways that machine learning works. Now we're into the how does it work part of this video. So there is something called supervised machine learning, where basically when the model is being trained, the data scientist or whomever is programming it, they might show it a picture of a dog and say, okay, this is a dog. And the model knows, okay, that's a dog. Great. Then it might show a photo of a cat and say, okay, this is not a dog. All right. And so then the model can tell, okay, this is a dog, this is not a dog. Now, the issue, though, is that supervised ML requires a lot of human input to verify that the model is doing it correctly. Okay? Okay, so since the model is being supervised, the human is saying, yep, that's a dog. Okay, this is not a dog, this is a cat, this is a dog, this is a dog. The model can learn and identify patterns, and then based on that, in the future, it can classify new data it receives and make a prediction based on what it has already seen of cats and dogs. It could analyze the photo and realize, okay, so some dogs are very big, some dogs are very small, but most cats are about the same size. Okay, a cat has a smaller nose than most dogs, and a dog has a bigger nose than most cats. So based on those patterns it can see in the photo, it can make predictions. Very cool. Beyond supervised machine learning, there's also unsupervised machine learning. And based on some inherent characteristics of those images passed in, the model can start to identify patterns and make its own predictions and its own classifications. Okay, that's very, very cool. And there are, of course, a couple different ways that data is structured in machine learning models, but most of the time it'll be structured in either a decision tree, where basically one decision, yes or no, leads you to another part of the tree, yes or no leads you to another part of the tree, and so on and so forth, until it can make a prediction with a fairly high level of confidence. Beyond that, there are artificial neural networks, which basically connect data that is similar or related. Okay, similar to how our brain works with different synapses and different nodes in our brains for creating thoughts and memories. An artificial neural network works just like that, where it makes connections and it makes observations based on patterns and related data that it already knows about. Very, very cool. Those are just two common ways that data is structured for a machine learning model. And now we should talk about why use machine learning in our apps. What's the point? Why should I use this? And I'm going to tell you the number one reason is that it makes it easy for you to personalize your app for your user. If you integrate machine learning, you can add features to your app that pay attention to what your user does and make suggestions and predictions based on that. If you've ever shopped on Amazon.com, you know when things pop up that say recommended for you, or based on this, we think you might like this other product. It uses a bunch of data from people buying things all over the internet, and then based on what other people have purchased, it can make a recommendation to you because of your shopping habits. It finds people like you that buy things like you and recommends things that you might like. That's machine learning. Okay, there's lots of great applications for this to make your apps tailored specifically to your user. The coolest thing is that machine learning is easy and available to use now for iOS. That's what we're going to learn in this course, and it's so cool. So let's go ahead, let's stop talking about machine learning at large, and let's dive into Core ML for iOS. We'll see you in the next video.